Today we're going to simplify some radicals. Okay, remember I told you yesterday we're doing little pieces and parts so that next week we can put it all together? So this is our next piece and part. Okay, so let's start off relatively simple. 2 square roots of 5 plus 7 square roots of 5. Anybody have any idea how we would add these two? 2 square roots of 5 plus 7 square roots of 5 equal 9 square roots of 5. Is this the square root of 5? Is that a variable? No, absolutely not, right? We know the value of the square root of 5. Is it kind of acting like a variable though? Yeah? Okay. What about this? Four square roots of 7. Everybody okay so far? Okay. Three square roots of 7 plus 4 square roots of 6. If it's acting like variables, can we combine them if they're not the same radical? No, absolutely not. Okay? It's just the same thing because we can't combine anything. There's nothing to simplify. Do I need to do any more adding and subtracting for you? You feel fairly confident in that? We will do some more in a minute because things are going to change. Okay? But before we do that, we have to do like this. I want you to simplify that. I'm not asking you to press something in the calculator and get a decimal, am I? Okay? If that's what it wanted you to do, it would say simplify, round to 3 decimal places. Or something like that, round to the 1,000th. Okay? But if it just says simplify this, here's what it wants. Do you know the square root of 20? Well, neither do I. Okay? But what I do know is the square root of 20 is really 4 times 5. Now, why did I choose 4 and 5 instead of like 2 and 10? Well, do you know the square root of 2? Do you know the square root of 10? That doesn't help me. Do I know the square root of 4? Yes, I do. So when I'm trying to decide how to break this number down, I want to choose something that I know the square root of. Does that make sense? Because one of the properties of square roots says that if the square root of 20 equals the square root of 4 times 5, that also equals the square root of 4 times the square root of 5. And didn't you just tell me you knew the square root of 4? 2. Do you know the square root of 5? Neither do I. That is simplified. Pardon? I don't have any idea what you're talking about. Can you show me what you're talking about? Can you show me what you're talking about after we make the video? What about the square root of 12? How should I break that down? 3 and 4. So that equals the square root of 3 times the square root of 4. So what's my answer then? Now, let me ask you a question. We have it written the square root of 3 times the square root of 4. Why did you suddenly write 2 square roots of 3? I'm not disagreeing that you know the square root of 4. I'm saying, why didn't you write this? Yeah, that's ugly. That's confusing, right? What if you accidentally drew this a little bit too long? Is that 2 inside or outside? Okay, so the same reason that we don't write this Or this, that just freaks me out just seeing it, right? We write the number that we do know the square root of, or a multiplier, in front of the radical instead of behind. Does that make sense? Yeah? What about this one? Nine and 8. Here. And then what? So I'll tell you right now, you will not get that answer right because it is not completely simplified. Oh, 8, right? 8 is what? 8 is 4 times 2, isn't it? Which also breaks apart like this. But we still have this 3 in the front, right? So this is really 3 times 2 times the square root of 2, isn't it? Which equals what? So while I agree with you that 9 times 8 is 72, hopefully when you wrote the 8, you also realized there's a square root in 8, isn't there? The 4, right? Could I have from the very beginning said 36 times 2? Whoa. Because that's 6 root 2 in one step instead of all the steps, right? Now, the good news is, doesn't matter how many steps there are, I still got the right answer, right? But don't we want to get the shortest way that we can? So, not only are we looking for any number that we know the square root of, what do we actually want? The biggest number that we know the square root of, right? Now, I'm telling you right now, when I did this problem the first time, I did 9 times 8. Because that was where my brain went. I know 72 is 9 times 8. But as soon as I wrote the 8, I was like, oh, dang it, there's a 4 in there. You see what I'm saying? How many ways is there to do this problem right here? Yeah, a lot. I showed you at least 2 right here, right? There's probably more. I'm saying don't give up right at the beginning. If you don't necessarily, if there's a ton of steps, don't give up, okay? Was there probably a shorter way? Yeah. But once again, we still got the right answer, didn't we? Okay? So be vigilant, be perseverant on this. Yeah? So when I give you a problem that looks like this, square root of 7 times the square root of 8, right? We did addition and subtraction up here already. What if I give you a multiplication problem? Is that something you freak out about now? Oh, no, absolutely not. You already know what to do, don't you? It's kind of backwards of what we just did, right? What is this? Square root of 56, isn't it? Is that simplified all the way? We'd have to think about it for a second, right? 56 is 8 times 7. I don't know the square root of 8 times 7, or the square root of 8, or the square root of 7, but 8 has a 4 in it, right? So the 4 has to be divisible into 56. And if I don't happen to know what that is off the top of my head, I have a friend who can help me. This friend never talks back to me. 56 divided by 4. Oh, look, 14. 4 times 14, which is 2 root 14. Because I don't know the root of 14, do you? Okay. Are we allowed to not know things in here sometimes? Yes, absolutely. We either can find them out by asking each other. We can find out by asking me. We can find out by asking our friendly neighborhood calculator. Whatever we need to do, yes? Any questions about this so far? So what haven't we done yet? Division. Okay? We did addition and subtraction. How are you feeling about that? We did multiplication way down here because we really needed to talk about simplifying first before we got to the multiplication, right? So now let's do division. Does that look like a division problem or does that look like a simplification problem? So it's like both. Okay. Here's what you need to understand. The square root of 2 over 5, does it make sense that I could change it to this? Knowing what you know about multiplication, does this make sense? Yes. Here's what you need to understand. We are not allowed to have a radical in the denominator. Just to be clear, what am I talking about when I talk about a radical? That symbol, right? We usually call it the square root symbol, but it's not always a square root symbol, so I'll just tell you we're going to call it a radical. Okay? Well, the only way I can simplify a number like this is by multiplying it by 1, right? Because multiplying it by 1 doesn't change its value, does it? But here's the deal. I get to choose which 1 I multiply it by, right? What if I chose to multiply it by the square root of 5 over the square root of 5? Isn't that 1? Anything over itself is 1, right? So this isn't going to change the value of this fraction, is it? It's just going to change how it looks, correct? If I multiply straight across the numerator, what do I end up with? Square root of 10, right? Because 2 times 5 is 10. If I multiply straight across the denominator, what am I going to get? Square root of 25, except you know that, right? That's 5. Huh. Do I have a radical in my denominator? So now I've simplified it, right? I'm done, right? Well, some people think I should cancel the 10 and the 5. Can I do that? If it was that fraction, yes, for sure I could do it, right? It's not that fraction. That 10 is inside the radical. When is the only time you can take stuff out of a radical? When you know the square root of it, right? The only time I can take stuff out of a radical is if I know the square root of it. I can't just start canceling numbers. First of all, we don't say canceling in Algebra 2. We're simplifying, aren't we? Okay? I can't just go simplifying stuff inside of a radical unless I know the square root of it. This right here, this is like a barrier of a protection for that number. We can help it lose a little weight, but we can't just go slashing stuff inside. So this right here is my simplified version of this fraction. Does that make sense? Okay. Here's why we can't always call it a square root sign. Right there. That's why we can't call it a square root sign. Why can't we call it a square root sign? Yeah, that's a cube root. That's why we call this symbol a radical. Because sometimes we use it for other roots besides just a square root. Does that make sense? Okay. So how do I want to simplify this first? We do want to split it up. Break it into its 2 parts. Whoops. That should be a 3. And that should be a 5, right? Now, most people's first inclination is to multiply top and bottom by the cube root of 5. Because that's what we did up here, right? Well, we did that up here because when I multiply straight across the denominator, that gave me something that I knew the square root of, right? If I multiply by the cube root of 5 here, I get the cube root of 25. Do you know the cube root of 25? Then I didn't do anything but simplify it, did I? We have to figure out what to multiply, what value of 1 to multiply it by, so that I know the cube root of whatever's inside here. What number that's related to 5 do I know the cube root of? So right away, somebody said 125. So either he knew the cube root of 125, or he remembered that I still haven't erased the chart on the board. And we can look up at the chart and say, oh, look, 5 is related to 125 because 125 is over in the cube root column, or in the cubed column. Does that make sense? What am I going to have to multiply 5 by to make it become 125? So my value of 1 then is the cube root of 25. Because when I multiply straight across in the denominator, I'm going to end up with a cube root of 125, right? which would be 5. What am I going to get in the numerator? Cube root of 75. Do you know the cube root of 75? Neither do I. That is my simplified fraction. Okay? I'd like to do one more of these if that's okay, but it's going to make you think. Are you ready to think? Yes? Okay, awesome. Cube root of 3/4. What do I want to do first? Split it up. Cube root of 3 over the cube root of 4. What value of 1 am I going to choose? What value or what number related to 4 do I know the cube root of? So I agree with 64. Is there another one? Yeah, what about 8? Wouldn't 8 be a little easier? Okay. Those of you who said 64, I'm not leaving you out. We're going to actually do that one in just a second. I'd like to try 8 first though, right? What do I have to multiply this by right here to make it become the cube root of 8, which is what I want? The cube root of 2. Cube root of 2. So what do I end up with in the numerator? Cube root of 6. And what do I end up in the denominator? Cube root of 8, which is 2. And I'm done, right? Okay, so let me go back here. Some of you said 16. So if I multiply numerator and denominator by the cube root of 16, first of all, that is not wrong. Have I made that clear to you? Okay. What do I get in the numerator if I do it this way? Cube root of 48, good. What do I get in the denominator? Cube root of 16, which is 4. Okay? But what I need you to realize is that there's a number inside 48 that I do know the cube root of. Right? There's more simplifying to do. Do you see that? What is it? What number do I know the cube root of inside of 48? 8, right? So this is actually the cube root of 8 times 6. And we know because of what we talked about a minute ago, simplifying these fractions, that I can separate this into 2 parts, right? Well, what is the cube root of 8? Do you know the cube root of 6? Me neither. What do you notice about this fraction? It can be simplified, can't it? I'm not trying to simplify the 6. I'm trying to simplify the 2 and the 4, right? That can be simplified, can't it? Because that's not inside the radical. Cube root of 6 over 2. Look, we got the same answer, didn't we? This one just had more steps, right? How many different ways are there to do some of these problems? A lot, okay? Be patient with yourself and figure it out as you go, all right? Now, I told you we needed to do a couple more addition and subtraction problems, right? You remember that? Here's why. 27 square roots of 6 plus 7 square roots of 150. Because at the beginning, all you knew is that these have to be the same, right? The only examples that I did were if they're the same. And if they're not the same, I said, it's just that, right? Well, this is true, right? That's just that. But what happens here? Do immediately we say, oh, we can't do that? Or do we look at these roots and say, can I simplify those? Can you simplify the square root of 6? Does it have any factors that you know the square root of? It does not. So I know that's going to stay the same. If I want to do anything with this one, what radical does this have to be? Doesn't it have to be the square root of 6? Don't they have to match? So we could use that as like a beginning thinking point, right? When I'm trying to decide, is there a number that I know that divides into 150 that's a squared number? We could say, what do I have to do to make this be the square root of 6? Oh, 25 times 6. Isn't that 150? Oh, don't I know the square root of 25? Awesome. I'm going to come over here to do my work, though, so I don't mess up my writing over here. 150 is the same as 25 times 6, right? Which becomes what? 5 roots of 6. So the only weirdness going on is I already have a 7 out here. And I have a 7 out here. And now I have a 7 out here. Is just like 75? Oh, no, that's ridiculous, isn't it? I multiply them, don't I? So what does that become? 35 root 6. Is that something I can now add? What do I get? 62 root 6. Done. Got it? What about this one? 7 cube roots of 2 minus cube root of 128. Can I simplify the cube root of 2 at all? No, so that's going to stay the same. In order for me to be able to do anything with this, what radical does this have to be? It has to be the cube root of 2, right? So 2 times what equals 128? Oh, that's so lucky, isn't it? Why is that so lucky? Do I know the cube root of 64? What is it? 4 cube roots of 2. 7 cube root of 2 minus 4 cube root of 2 equals? Perfect. How do you feel about adding and subtracting? Whether they're the same or whether they're different, you're feeling okay? How do you feel about multiplication, like this one down here? Better since you know about simplifying? How do you feel about division? Yeah? So the only other examples that I need to show you are examples like this. When I say simplify, when there's no numbers involved, it's just variables. We have to remember our exponent rules from yesterday, don't we? I'm going to take this pieces and parts if that's okay with you. Okay? The fifth root of x to the ninth. Fifth root means what times itself times itself times itself times itself equals that number, right? So are you okay if I split this into these two parts? Remembering our rules from our exponent folder rule from yesterday. Right? If I'm multiplying like bases, I add the exponents. So can I change this into this? Can I go backwards this way? Why would I change it to this section right here? Do I know the fifth root of x to the fifth? What times itself times itself times itself times itself equals x to the fifth? X. Do I know the fifth root of x to the fourth? No. That stays just like that then, doesn't it? What about the fifth root of y to the 10th? Do I need to split it up into 5 and 5? What times itself times itself times itself times itself is y to the 10th? Y squared, right? That's just y squared. Because y squared times y squared times y squared times y squared equals y to the 10th, doesn't it? So it's just that simplified, isn't it? What about the fifth root of z to the 11th? Say it again. 6 and 5. Yes. But why not z to the 10th and z? Because don't I know the fifth root of z to the 10th? What is it? Z squared. Do I know the fifth root of z? No, so I just leave it inside. Now let's put these all back together to be able to write the answer. When I took the fifth root of y to the 9th, I got x to the 5th, x, and then the fifth root of x to the 4th, right? So I have an x and a fifth root of x to the 4th. When I took the fifth root of y to the 10th, I got y squared. And when I took the fifth root of z to the 11th, I got z squared and a z inside the fifth root still, right? So this is my simplified answer from there. You want a hard one? Of course you do. Excellent. The fourth root of 405 x to the third y to the third over 5x to the negative 1 y. This one just looks messy, doesn't it? Could I do something to clean it up first? So I could simplify what's inside without even messing with the fourth root yet, right? Okay. If I do that, what is 405 divided by 5? Because those are just my constants in the front. Shouldn't I just divide them? So what's 405 divided by 5? And if you didn't know it was 81 off the top of your head, what could you do? For sure, right? X to the third over x to the negative. Oh my gosh, it's so sad. Where does it want to go? If I move it up, I have x to the third and x to the first. What does that give me? X to the fourth. What about here? If I'm dividing like bases, what do I do with the exponents? So 3 minus 0? Oh, that's not 0. That's a 1, right? Even though there's not 1 written, we know that, right? So y squared. Is this so messy now? Do you know the fourth root of 81? If you don't, is that something you know how to press on the calculator to know? If you don't, can I show you real fast? Okay. I want to make a calculator page. Look at this button right here. See the blue writing above the button? It says n root x. So if I use control in that button, it lets me put any root in there, not just the square root. So if I put the fourth root of 81, it will tell me right away that it's 3. Does that make sense? 3. Do I know the fourth root of x to the fourth? X. Do I know the fourth root of y squared? No. Done. Questions? How do you feel about adding or subtracting, regardless of whether what's in the root are the same or different? You okay? How do you feel about just simplifying a basic radical? Good. How do you feel about multiplying? And how do you feel about dividing? And then again, just simplifying, especially when there's variables involved. So there's still some questions on this. So if you have questions when you're working, what should you do? Oh, ask. I'm so proud of you. Any questions, guys, for real? You good?